All right, hello once again, Jeff Scott of Rankin Technical College. I've been going over the online PDF textbook, AppInventor2, Create Your Own Android Apps by Wolber, Abelson, Spertus, and Looney. We are smack dab in the middle of Chapter 5, which is our LadybugChase program. And the next step we want to do is add the AFID or AFID. Specifically, it should flit around the field canvas. If the ladybug runs into it, it therefore eats it, so the energy level should increase and the aphid should disappear to be replaced by another one a little later. All right, so the first step, as it says, we need to undertake is to add the aphid, is to go back to the designer and create another image sprite and don't place it on top. Okay, so the first thing we want to do is go back into here, go back into our designer, move that over here to make sure it's not in the same place. We'll add another image sprite. Okay, and we will set its picture property. Well, first we're supposed to rename it AFID or AFID. Okay, so that's done. Set its picture property to the AFID image. So there it is. Set the interval property to 10, so like the ladybug, it moves every 10 milliseconds. Set its speed to 2 so it doesn't move too fast so that the ladybug is able to catch it. Otherwise, it would just, it would die every time. Don't worry about the X's and Y's because we're going to be setting those in the blocks editor. As they mentioned, by experimenting, the author has found it works best for the aphid to change directions about every 50 milliseconds. It says one approach to do this would be to create a second clock with time interval of 50. One thing you have to be kind of leery of is you don't want to just keep creating and creating and creating controls. All right. So the author here says they'd like to try a different technique so we can learn about the random fraction block, which returns a random number greater than or equal to 0, but less than 1. So we want to update our AFID procedure so that we add to it this. So we want to create a new procedure called update AFID, and then we want to add the call to it. Right under the call to update ladybug, we want to add the call to update AFID. All right. Now, notice under the how blocks work, this is the bottom of page 87 in our text. Whenever the timer goes off, which again is 100 times per second because it's set to 10 milliseconds, both update ladybug and update AFID are called. The first thing that happens in update AFID is that a random fraction, so it's a random number between 0 and 1, is generated. It's less than or equal to 0, which in this case would mean no movement, and it's greater than or equal to 0, and it's less than 1. If the number is less than 0.2, the aphid will change its direction to a random number of degrees between 0 and 360. If it's not less than that, it'll stay right where it is. So 80% of the time it won't move is what they're saying. All right, so we have to add this routine right here. Update aphid or AFID. So we'll go back to our blocks editor, go to procedures. In fact, let's take this block and collapse it. And we're going to add a new procedure. Call this update AFID. And we want to put in here if, and then we want an if block. All right, and we want it to be if a random fraction is less than 0.2. Okay, well that's not going to be enough right there. We do need that, but what we're going to need to do is we're going to need to put in a less than block. I believe. I think we're going to do that like this. Change the sign to less than. Put in random fraction here, and we want that to be 0.2. All right, so if that's the condition, then we want to set the aphid heading and we want to set that to random integer between 0 and 360. And we will manually go in here and change this to a 0. We'll manually go in and change this to 360. And then we have to call update aphid in our update Ladybug routine. That is the wrong one. That's our clock 1 timer. So we're now calling Ladybug. Let's duplicate that. And we'll update aphid here. Okay, I believe that's everything. So again, what that's saying is generate a random number every 50, I think it's 50 milliseconds. And if that number is less than 0.2, so if it's less than 2/10, then move it around in a random area on the screen. Otherwise, since there's no else, do nothing. All right? The next step in the is for the Ladybug to eat the aphid when they collide. It says, fortunately, AppInventor provides blocks for detecting collisions. To handle what happens to the Ladybug when the Ladybug and aphid collide, let's create a procedure called eat aphid. It's going to do all this. Increase our energy level by 50. Okay, causes the aphid to disappear, causes the aphid to stop moving, and causes the aphid to move to a random location. So we want to do this. I'm checking my time here. We're at 8 minutes. We should have plenty of time to get this done. So let's collapse this. I don't think what's bad is there's no way to lasso all that stuff. So if I want to move them up, I've got to move them up individually, it looks like, which I don't really like, but and we'll even collapse that one. So now we're going to add a new procedure, which is going to be called eat aphid. And what do we want to do in here? We first want to set our global energy level to get our global energy level plus 50. Now I think we have that in here someplace. I don't really want to look for it. Okay. So we want to do a set and a get in here. To get plus 50. So we need a plus block in our math area. Okay? We want to set our aphid visible to false and our enabled to false. There it is. Then we want to call our aphid move to. And you can see what we have for our X and the Y. The good news is we only have to do one of them, and then we should be able to do a copy. So this is a random integer. Again, go back to our math, find our random integer. And we want to go from 0, so that's 0. This we don't want here. Notice when I remove this, what's going to happen is up here, I'm going to get the triangle, because now it's going to tell me that I'm missing something in here. Eventually it'll come up on there. All right, but I want that to go to fieldCanvas.width minus aphid.width. So we need to bring in a minus block. This is going to run into the one right here. So I'm going to try to bring these down so that you can see at least what's going on here. All right. So fieldCanvas.width minus aphid.width. All right, and we're going to take that, and then for the Y, we're just going to duplicate this and make some subtle changes here. Okay, let me move these down. And we want this one to be field canvas height and aphid height. So change that from width to height, and that from width to height. And I believe that's everything that we wanted to do in this section. So as it says here, whenever aphid is called, it's going to add 50 to the variable energy to make sure that the ladybug does not die from getting its from having its energy level set. All right, so it's set to a number, you know, so if we don't want it to run down to 0, how's that? Because if it does, that's one of the ways, as we mentioned, the game ends. Okay, so we add 50 to it. The visible and enabled properties are set to false, so it looks like it not only stops moving, but it disappears. Then it generates a new call, so it appears in a new direction. All right? Because if you just left it where it was, the ladybug could just keep eating it. So we have to next talk about how to avoid a collision here. Let's do that. I think we can do that and go over it quickly. And then we will stop this particular part of the lecture. So when the ladybug collides with another image sprite, in this case the aphid, the ladybug.collideWith is called, with the parameter other bound to whatever the ladybug collided with. Right now the only thing it can collide with is the aphid, but later it'll also be able to collide with the frog. As it says, we'll use defensive programming here to explicitly check that the collision was with the aphid. If it's with the frog, the game should end. So, but if it's with the aphid, we should be adding 50 to our energy level. There's also a check to confirm that the aphid is visible. Otherwise, after an aphid is eaten, but before it reappears, it could collide with the ladybug again, which we don't want to have happen. All right, so we want to do this right here. So we want to do the ladybug collided with. I'm again going to come in here and collapse this. All right, and we want an if block in here. It's just an if then. And we want this to be, and it's pretty complex, so we need an and in here. And we want in equal signs, because the get other is supposed to be equal to aphid. So we need an equal sign in here. And we want the get other I don't think we have a variable that's called other. There's our variable, and that's the energy level. There's the other. So get other, it's equal to aphid. Not sure if that should be put in here as a text block or not, but that's what I'm going to try to put it in as. Oh, that isn't right. We don't want it that. We want it to be... There it is. And aphid.visible. If that's the case, we want to call eat aphid right there. All right, so if there's a collision and what we collided with was the aphid, and indeed the aphid is visible, we don't want to be able to collide with it when it's disappeared. So it's got to be an aphid we collided with, and that aphid has to be visible. If that's the case, call eat aphid, and remember what eat aphid will do, we saw that down here, is that will add 50 to our energy level, make the current aphid become invisible, make it stop moving, and make it reappear on some other place on the screen. Now the author mentions here, and we'll finish up this section on this, defensive programming is a practice of writing code in such a way that it is likely to work even if the program is modified. In the figure, the test, we put other equal aphid. It's not strictly necessary because the only thing the ladybug can currently collide with is the aphid. But you never know what you're going to add. In this case, we are going to add the frog, but you never know in the future what you're going to add. So as it says there, having a check like this will prevent the program from malfunctioning if we add another image sprite but forget to change the ladybug.collideWith method. Programmers generally spend more time fixing bugs than writing new code. So it's worth it to take some time and think about what's going on here. So I'm going to pick it up on the next one with the return of the aphid.